Greetings. So in this one, let's take, for example, this example. Let's take a definite integral from pi over 2 to pi of sine x times cosine x dx. Let's see what that gives. So the first step would be to solve the antiderivative. That means the so-called indefinite integral. And then all the difference there is for a definite integral is it has these bounds. And so all one does is takes this result, we will now solve the thing I wrote here, and plug in this bound, and then from that value subtract plugged in this bound. So let's first solve this, and then I'll show what this is directly equal to. So this thing we will use u substitution to solve. Okay, so for now we separate it and we want to use u substitution. U substitution means I can take something in the argument here and call it u, this or this. So for example, I use u here. So sine x I say is u. So that means u is actually u of x because it's a function of x. Because sine of x is a function of x. And then I can do the following. I can take a derivative of u, which is du over dx. And that is cosine x. And if I have dx here, I want to know what it is in terms of du and cosine x. So from this equation, I can multiply both sides by dx. And then divide by cosine x. So dx would equal du over cosine x. So I can replace in the original integral all these things. Dx by this and sine x by this. So this becomes u, and this becomes du over cosine x. But when there is this fraction involving du now, that basically replaces the dx, we can put the denominator inside the argument of the antiderivative. So it can be placed from here, it can be placed to here. But that reduces to 1. So that sort of disappears. So what we have left is this. And now this is like if it was x, u, like if it was x, but it's u. Now it's simply in respect to the independent variable u. And it is a linear function, u to the first power. So the antiderivative is simply u squared over 2. Raise the power by 1 and divide by the new power. And add a constant, because it's an indefinite integral. Now, whatever c is as a constant, when we take a definite integral, so from a to b, that will be equal to not u squared of 2, but actually a squared of 2 plus c minus, and then plug in b squared of 2, so the upper bound plugged in into the function, over 2 plus c minus, plug in the lower bound, a squared over 2 plus c. These two c's would cancel out like this, so the constants don't appear when we plug it into a definite integral. Therefore, what we really care about is what we got as the u squared over 2. Right here. So what we will now do is basically use this for the sine x cosine x dx. U squared actually over 2 has a meaning in terms of what u was set to for the initial integral, that is sine squared x over 2, because u was set to be sine. So that means that basically the antiderivative is sine squared of x over 2, And now, because it's a definite integral, all it means is we evaluate it at the upper bound and subtract evaluate it at the lower bound. So it goes from pi over 2 to pi. So that is sine squared of pi over 2 minus sine squared of pi over 2 over 2. So what is that? Well, sine of pi is 0. So this whole first term is 0 squared over 2. That's 0. And minus sine squared of pi over 2. Sine of pi over 2 is 1. And sine squared is 1 squared over 2. So all this together is minus 1 over 2. So therefore, the result for this initial question is minus 1 over 2. And that's it.